Okay, for the PowerPoint, so like basically, so we have three cases. So one is like a circle, so and two chords, so like just cross inside the circle. So we have AB and we have DC, and then so the cross at intersected at O, and then so we have AO times OB equals DO times OC. Okay, this is the first case. Second case, so one chord and so it's a BA, and then so another line, so like the AP, this is tangent to this circle. And then so we have the formula, so it's AC times AB, so equals AP squared. So this is the second formula of the PowerPoint. And the third case, so is like just like a two chord extended and intersected at the outside of the circle. So we have AB and then AC intersected at A. And then so we have AE times AB and equals AD times AC. So this is the third form of the PowerPoint. So for different cases, so we may need to use the different form. Okay. And also we have other two very important theorems. So like I should mention here. So like maybe like we will meet those two. So one is called the Stewart theorem, and given a triangle ABC, and then so given a line, so like that's like inside the triangle. So like that's the D. Okay. So if the length, so like marked in this way. So and then so we have a very simple formula. So like the M times A times N plus D times A times D equals B times M times B plus C times N times C. So like usually, so like if you try to memorize this one, so like it looks like it's a little bit complicated, but like we can memorize this one easily. So usually, so like somebody so make this joke. So like a man and his dad put a bomb in a sink. So you see here, MAN, man plus dad, and equals bomb plus sink. So like this is like you can memorize this way, and then so this formula so becomes much easier to memorize. Okay, and then so, but very important, so you need to remember this like this picture. So like if M and N is reversed, so this formula is not true. So you need like the mark, so like this is A, B, and C, and this side, so it's M and N, and then this is C, and this is the B, and the middle, so it's D. Okay, so that's for the Stewart theorem. And to prove this theorem, so it's also it's not hard. So or we should say definitely it's, so you can use a law of cosine to prove it. So it's not a big deal. And also we have another theorem. So this is also like a very popular. So in I think in mass contest, so like it's very often. So it's called the bisector theorem. Okay. So given triangle ABC, and then so AD is the bisector of the angle A, and then so we have AB over BD, so equals AC over DC. So this is a bisector theorem. And also we can prove this one use law of sine easily. Okay, the next one, so like we can look at this, look at the problems in this section, so PowerPoint. So let's look at number 2. So this problem, so like say we have 2 arcs, so AC and BC, and then so the center, so like so the arc AC so has a center, so B, and the arc BC has center A, and then so like also we have another circle, and then so like this circle is inside, so it's A, B, C actually. So like this, if you draw the diagram, so like the arc AC and AB and the line AB. And then so you have another circle inside of this ABC. And then so the circle so tangent both arcs and also the line AB. Okay, and also given the arc BC is 12. And then the question is find the radius of the inside circle. Okay, that's the problem. Okay, here, so like first, so like given this arc, BC is 12. So if you look at this picture, and then so because the chord AC and the chord BC, and it's same as the AB. And then so this chord so should be just 1/6 of whole circumference of the circle, so centered at A, and the radius with AB. Okay, so that's said that means like the circumference for that circle so should be 6 times 12, so equals 72. And then so if AB is the radius of the circle, so then so that's we have the circumference, so it's 2 pi r, so equals 72, so r equals 36 divided by pi. So that means we can find AB equals 36 divided by pi. So the next one, because the inside circle is tangent to the arc BC, so BC is a part of a circle centered at A, and the radius is AB. So this means to give you so like the very important for the tangent of circles. So we have the center so and the tangent point must be in the same line. So this means that this is the A is the center of the bigger circle, and O is the center of the small circle, and then so D is the tangent point. So that means so like D, O, and A must be in the same line. Okay. And now so like if you look at this A, D, and E, E is the tangent point of the small circle and AB. So if you look at the AE and AD and AF, and then so we can apply like the power of point, the second form. Okay, here. So we have a tangent line, we have a chord pass through the circle. So based on this second form, okay, based on this the second form PowerPoint, so then we have AF times AD, so equals AE squared. So AE so is just like a half of AB. So that means it's a half R AE. And then so AD is just the radius of the bigger circle, so it's a R. Okay. And AF, so it's actually, so it's the big R and minus 2 times the small r. Small r is the radius of a small circle. So then we plug in, so we have r minus 2r times r equals a half r squared. So based on the formula is here. And then so we can get those. And then so plug in, and so cancel r first, and then so we can find the small r equals 3/8 big R. And big R equals pi over 36 over pi. And then so simplify, so we got like little r is 27 over 2 pi. And then so we want to find the circumference of the little circle. And then so it's 2 pi little r, so equals 2 pi times 27 over 2 pi, so equals 27. So that's what we need. So for this problem, so like first, so just draw the diagram, and the key point is here. So like is those D and O and A are in the same line, and also like we apply the like the power point here. So like for this so AE, AF, and AD, and then so we can get the answer. Any questions? Okay. Okay. The next